Hello students, hello everyone. Welcome to Senior College Mathematics. Topic of discussion is matrices and determinants. If you are in senior college, you are preparing for WAEC, for NECO, for GC, for NAPTEP, for JAMB, or any other external exams into high school, this lesson is for you. You are in the right place. Petakus Education Community. Lesson 4, General Matrix Multiplication. In lesson 3, I taught scalar multiplication of a matrix. But in this lesson, we'll look at multiplying a matrix by a matrix, not a scalar now. That is general matrix multiplication. Before that, for updates, follow Petakus Educom via YouTube at Petakus Simplified Maths. To do that, subscribe to this channel, like and share this video to your friends, your classmates, your colleagues. Facebook, fb.me/Petakus Educom, Instagram, Petakus EC, Telegram, t.me/Petakus Educom, WhatsApp through this mobile telephone number. In all of these platforms, you get updated from time to time about what is happening at Petakus Education Community, where you have access to quality, unlimited, and simplified mathematics teachings in series. Okay, multiplication of matrices. When a matrix A is multiplied by another matrix B, a single matrix results. When you multiply a matrix by another matrix, you get a single matrix in which elements are obtained from the sum of products. That means you multiply the element and add them. Sum of the products of the corresponding rows of A and the corresponding columns of B. Let's continue with the explanation. Two matrices A and B may be multiplied together provided, look at the condition now, provided the elements in the column of matrix A are equal to the number of elements in the row of matrix B. The meaning is that for you to multiply two matrices, the number of rows in the first, the numbers of rows in the second matrix must be equal to the number of columns in the first matrix. In other words, you can multiply two matrices if the number of columns in the first matrix is equal to number of rows in the second matrix. So in this multiplication, the dimension must not be equal. What must be equal is the number of columns in the first matrix must be equal to the number of rows in the second matrix. In general terms, when multiplying a matrix of size m by n by another matrix of size n by p, the resulting matrix has the size m by p. Okay, now look at it. Matrix A is m by n, matrix B is n by p. For me to multiply, I'm going to check if the number of column in matrix A, I told us in the order of the matrix you have rows before column. So in matrix A, the column is n. In matrix B, the row is M. See that? So you are checking the numbers of columns in the first matrix to the number of rows in the second matrix. Since they are equal, it means that A, B, the two matrices can be multiplied, and the dimension of the resulting matrix would be number of row in the first matrix and number of column in the second matrix, that is M by P. To emphasize more, what I'm simply saying is that product AB is defined only if the number of rows of matrix B is the same as the number of columns of matrix A, or if the number of columns of matrix A equal to number of rows of matrix B. Then the product AB is another matrix that can be C. Okay? Okay? One more time, let me repeat that. You only multiply two matrices if the number of columns in the first matrix is equal to the number of rows in the second matrix, or the number of rows in the second matrix is equal to the number of columns in the first matrix. Anyhow you want to check it from, or any side, just make sure that this condition is satisfied before you can multiply the two matrices. Okay? So consider the illustration below. Look at matrix A with the corresponding elements and matrix B. So for me to multiply, or for me to know if multiplication is possible, look at the number of columns in the first matrix is equal to number of rows in the second matrix. You see that now? So the product AB is another matrix C whose elements are this, but the dimension now is the number of rows that are left in matrix A and the number of columns that are left in matrix B. So I'm going to have a 2 by 2 matrix. So how do you get the first element here? C11. That is element in first row, first column. So you take the element in first row of matrix A to multiply element in first column of matrix B. Element to we say sum of the product. So you take the product and add. So you have A1 times D1 plus B1 times D2 plus C1 times D3. When you multiply and add, you get the first element. To get the second element, element in second row, first row, second column. 1, first row, 2, second column. You use the same first row of matrix. See now, you are still in first row, second column. First row of the first matrix, second column of the second matrix. So the same A1, B1, C1 to multiply the second column. This is the result that you have. A1 times E1, B1 times E2, C1 times E3. Then you now move to C21. C21 means the second row of the first matrix multiply the first column of the second matrix. the first row of the first matrix times the first column of the second matrix. That is using A2, B2, C2 to multiply D1, D2, D3. That is what you have here. A2 times D1, B2 times D2, C2 times D3. Then the element in second row, second column C22. It means use the second row of this first matrix to multiply the second column of the second matrix. That is A2 times E1, B2 times E2, C2 times E3. So this is how matrices are multiplied. In the above illustration, that is in AB, the product AB, A is said to pre-multiply B, or B is said to post-multiply A. It's either A pre-multiply B or B post-multiply A. So let's take examples and use this illustration to multiply matrices. The summary is that you use the first row to multiply the two columns of the second matrix. Then the second row to also multiply the two columns of the second matrix. So when you are using the first row, you get the first row in the answer. If I use the second row, you get the second row in the answer. Okay. Properties of matrix multiplication. If A, B, and C are matrices with sizes such that the given matrix products are defined, so the size helps you to know if you can multiply or not, and K is a scalar, then the following properties are true. 1. Associative property of multiplication. In order, if you have three matrices, you multiply the second and third together, then multiply it by the first. It's the same thing as multiplying first and second, then multiply by the third. Distributive property. This one has two forms. Distributive. If you add two matrices and multiply by the first one, it's the same thing as multiplying the second and third matrices by the first one before adding them in this form. So you can take this shape, or you add the first two matrices, multiply the result by the third one, or you multiply the first two matrices by the third one before you add. You can also have a scalar. If you multiply the product of AB, if you find the product of AB, multiply it by a scalar, is the same thing as the first matrix multiplied by the scalar before multiplying by the second matrix. It's also the same thing as multiplying the second matrix by the scalar before multiplying it by the first matrix. The fourth one then, if A and B are two matrices, then AB may not be necessarily equal to BA. That is, the commutative property of matrix multiplication is not always defined. It can be defined but not always. That is, commutativity of matrices multiplication is not necessarily defined except on the ground that the sizes of the given matrices are equal. In other words, when you have matrices with 2 by 2 dimensions or 3, that is equal matrices. Or if you multiply square matrices, then you can have commutative property. That is the only way. When you multiply square matrices, number of rows and column, they are equal. in both matrices. So look at matrix A here. This matrix A, the size is m by n. Look at matrix B, the size is m by n. In this case, you can have AB equal to BA. That is the only condition for us to have commutative property of matrix multiplication. Okay? So example 10, find the product of A and B. If matrix A is equal to this, matrix B is equal to this. If you check, matrix A is 2 by 2, matrix B is 2 by 2. This means that the number of columns in matrix A is equal to the number of rows in matrix B. That means we can multiply matrix A by matrix B. And our result will be 2 by 2 matrix. Okay? So this is AB now. This is AB, and the result is matrix C with this entry. So for you to get C11, like we said, you take the first row to multiply the first column. See my arrow now? First row times first column. Corresponding entry to entry. That is 5 times 7 plus minus 2 times minus 3 now. See that? So you have 35 plus 6, that is 41. Minus is positive. Then to get the second entry in the first row, you use the same first row to multiply the second column. That is 5 times 1 minus 2 times 4. So you have 3 minus 8. Plus times minus is minus. That is minus 3. To get the first element in the second row, that is 2, 1, 2, 1. You go to second row in the first matrix to multiply the first column in the second matrix. That is 0 times 7 plus 3 times minus 3. You have 0 minus 9 equal to minus 9. To get the second element in the answer, the second element in the second row, you use the second row of matrix A to multiply the second column of matrix B now. That is 0 times 1 plus 3 times 12. And that gives 0 plus 12 equal to 12. So you replace the element. So AB is equal to 41 minus 3 minus 9 and 12. And 12. Okay? Another example to explain further. Example 11. If A is a 3 by 3 matrix given by this, and C is a 2 is also C is a 2 by 3 matrix, is a 3 rows, that is 3 by 2 matrix, 3 by 2 matrix. Okay, let's take it again. If A is a 3 by 3 matrix given as this, so A has 3 rows and 3 columns, and C is a 3 by 2 matrix given as C, that is 3 rows, 4 minus 1, 2, 0, 3, 3, and 2 columns, 4, 2, 3, minus 1, 0, 3. Then find AC. First you check is the dimensions. So for the first matrix, it is 3 by 3. Second matrix, 3 by 2. So you must check that the number of columns in the first matrix, 3, is equal to the number of rows in the second matrix 3 before you can multiply. So our result will be 3 by 2 matrix. That is number of rows in the first matrix and number of columns in the second matrix. So you write a 3 by 2 matrix as the solution. That is C11, C12, C21, C22, C31, C32. So you look for C11. To get C11, the first row of the first matrix multiply the first column of the second matrix, element by element, then you add. That is 3 times 4, 1 times 2, 0 times 3. So you have 12 plus 2 plus 0 equal to 14. Then the same first row multiply second column to have C12. To have C12, that is 3 times minus 1 plus 1 times 0 plus 0 times 3. So you have minus 3 plus 0 plus 0, that is minus 3. What you have done now is the first row. You move to the second row. For the second row, you use the second row of matrix A to multiply the first column of matrix B, element by element. So you have 2 times 4, 1 times 2, 4 times 3. That is 8 plus 2 plus 12. That is 22. To get C22, still on the second row, you use the same second row to multiply the second column of matrix C. That is 2 times minus 1, 1 times 0, 4 times 3 equal to minus 2 plus 0 plus 12, and that is 10. You move to the third row. Third row, you use the third row of matrix A to multiply the first column of matrix C, element by element. So you have 5 times 4, 6 times 2, 7 times 3. So you have 20 plus 12 plus 21. That is 53. To get the second element in the second row, second element in the third row, that is C33, you use the same third row to multiply second column. Third row to multiply second column. So you have 5 times minus 1, 6 times 0, then 7 times 3. 7 times 3, you have minus 5 plus 0 plus 21 plus 21, and that is 16. That is 16. So this is the final result, matrix AC. So C11 is 14, followed by minus 3. Then C21 is 22, C22 is 10, C32 is 53, C31, that is the element in first, the element in third row first column, C31, third row first column is 52, is 53, while the element in third row second column is 16. So this is the result of multiplying matrix A, that is 3 by 3, by matrix C, that is 3 by 2, and the result is a 3 by 2 matrix. Okay, one more example. Okay, Example 12, given that matrix P is equal to this, matrix K is equal to this, find matrix PK. The two matrices are 3 by 3. Without doubt, number of columns in matrix K is equal to number of rows in matrix K. Number of column in matrix P equal to number of rows in matrix K. So our result would be a 3 by 3 matrix denoted by this. So you look for 9 elements, 3 elements in each of the 3 rows. So let's continue. So this is matrix P again, this is matrix K, and this is the result we are expected to have. So the first element C11, that is the element in the first row, first column. So you use the first row of matrix P to multiply first column of matrix K. So you can see there, this is the multiplication, element by element. When you do that, you have -8 with care. Then to get C12, that is the element in first row, second column. You use the same first row to multiply second column of matrix K. Element by element, you have it in this form. When you multiply and add, you have -2. To get C13, that is first row, third column, you use the same first row to multiply the third column, element by element. So you have 2 times 2 minus 1 times 3, then 3 times -2 in this form. When you simplify it, you have -5. -5. You move to the second row now, to the second row, and the first element there is 21. 21 means second row, first column. So you take the second row of matrix B to multiply the first column of matrix K. So you are doing everything again, but using second row. When you do that, you have this element by element. When you simplify, you have 4. 2, 2, that is C22. It means second row, second column. So you use the same second row of matrix B to multiply second column of matrix K. When you do that, element by element, this is what you have. 5 times 1, 1 times 1, 5 times 1, 5 times 1, 1 times 1, then you have -2 times -1, element by element. When you simplify further, you have 8. Then you move to C23, that is second row, third column. Use the same second row of P to multiply third row of K. Element by element, you have 5 times 2, you have 1 times 3, -2 times -2. Simplify further, you have this, that is 17. Then C31, you are now in this third row of the solution matrix. So C31 means the third row of matrix P times the first column of matrix K. So we are now in the third row, doing everything again, that is multiplying the 3 columns of matrix K by the third row of matrix P. So you start with the first row against the first column again. Element by element, you have 2 times 0, 2 times minus 4, 3 times minus 4 again. When simplify further, you have minus 20. C 3 2 means the third row of the same matrix P times the second column of matrix K. Matrix K, element by element, you have 2 times 1, 2 times 1 again, then 3 times minus 1. When you simplify, you have 1. C 3 3 means the third row of matrix P times the third column of matrix K. Element by element, you have 2 times 2. You have 2, that is this 2 now. This 2 times this 2. That's the meaning element by element. Then again, you have 2 times 3. 2 times 3, and you have 3 times minus 2. That will give us 4 plus 6 minus 6, and that is 4. So at the end, you replace this entry with what they stand for in the solution. C11 is minus 8. C12 minus 2. C13 is minus 5. You go to C21 is 4. C22 is 8. C23 is 17. The third row, you have C31 minus 20. C32 is 1. C33 is 4. So this is how matrices are multiplied. The condition again, you can state it in two forms. The number of columns in the first matrix must be equal to number of rows in the second matrix, or number of rows in the second matrix must be equal to number of columns in the first matrix before multiplication can be done. So take your time to go through it. All right, end of lesson 4. Thanks for watching and learning with Petakus education community. Don't forget, watch out for more from the voice of Petakus. For questions and inquiries, use the comment section. We'll attend to them. For the complete package of this topic, lesson 1 to 11 for offline usage, you can contact the voice of Petakus via this WhatsApp number or through the email address. At a very little token, you get the complete package delivered to you. Lastly, if you are not safe, your life will be in crisis. To avoid that, you give your life to the one that can save you. That is the Lord Jesus Christ, and you confess him as your Lord and Savior every day of your life. If you are saved already, I tell you, big congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Take good care of yourself. Stay out of trouble. Stay well. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Use your hands and your brain to work genuinely, and the Lord will bless you. Goodbye for now.